Hello friends, now we are starting a formula. We are going to prove one formula to find out equation of plane passing through the intersection of two planes. So first let us consider the equation of two planes. So let equation of two planes be. So equation of first plane is r bar dot n bar is equal to let us denote here this value say by d scalar r bar dot. Already we know that equation of plane can be find out applying this formula. R bar dot n bar is equal to a bar dot n bar, but on this side dot product of two vector is what? Scalar quantity. Here I am denoting scalar by what? D. And equation of second plane is r bar dot n bar is equals to d. Since two planes are there, so denote the vector perpendicular to the plane first by n1 bar and the scalar by d1, and in the second equation denote this vector perpendicular to the second plane by n2 bar and this scalar by what? d2. So this implies that these equations, let us denote this equation say by equation first and this by equation number second. So which implies that this plus d1 on this side will become what? Minus d1, means first equation can be written as r bar dot n1 bar minus d1 is equals to 0, and second equation can be written as r bar dot n2 bar minus d2 is equal to 0. Just we are trying to get 0 on the right hand side, so for that purpose we are using transformation. Plus d1 on this side will become minus d1 and plus d2 on this side we will get minus d2. Now suppose that if two planes intersect each other, so let us consider here say these are what? Two planes. Let this will be, this flat surface means what? One plane, and this flat surface means what? Second plane. And we can observe that if these two planes intersect each other, their intersection is point or their intersection is a line. So we can observe that if two planes intersect each other, then their intersection is what? Line. And from this line how many planes can be passed? Here we can observe that every page is like what? Plane, a flat surface, and all these plane passes through this line of intersection. Means if two planes intersect each other, their intersection is what? Straight line. And from this straight line how many planes can be passes? Infinite number of plane can be passes, and we are going to prove one formula to find out equation of such plane which passes through the line of intersection of two planes. Okay, so therefore equation of plane passing through intersection, passing through line of intersection of plane first and second is, in the first bracket write down first equation of plane. What is the first equation of plane? R bar dot n1 bar minus d1 plus lambda into, where lambda is nothing but a scalar, and value of, in the second bracket write down second equation, r bar dot n2 bar minus d2 is equals to, let us see what we'll get on the right hand side. Already I have written here 0 is there on the right hand side. See why we are getting 0? Because value of this first term is equals to what? 0, and here value of this second, the value in the bracket, its value is also equals to what? 0. 0 into lambda is 0, and 0 plus 0 will be equals to what? 0. Let us simplify it. Already we have got a equation which is, or we have got a formula which can be applicable to find out equation of plane passing through the intersection of two plane. Let us simplify it and write down it in simplest form. So r bar dot n1 bar minus d1, keep it as it is. I am multiplying by lambda to both the terms in this bracket. So what we'll get here? Lambda r bar dot n2 bar minus lambda d2 is equals to 0. Now how many terms of r bar are there? Two terms. We are collecting or we are taking r bar dot common from these two terms. So if I am taking r bar dot common from first term, here we will get n1 bar and here we will get plus lambda n2 bar. Okay, just we have collected the terms of what? R bar dot, and even we have taken R bar dot common from these two terms, and remaining term let us collect on another side. Minus d1 on this side will become plus d1, and minus lambda d2 on this side will become what? Plus lambda d2. And this formula is applicable to find out equation of plane passing through the intersection of two plane. So this is a required vector equation. So in this way we have got a formula to find out vector equation of plane passing through the intersection of two plane. See, to apply this formula, which values are required? n1 bar, n2 bar, d1 and d2. So n1 bar, n2 bar, d1 and d2 we will get from the equation of two planes. Once these values are known to us, substitute all these value in this formula. Then only the remaining part is to find out value of what? Lambda. Because see, two plane intersect. अगर दो प्लेन इंटरसेक्ट हो रहे तो उनका लाइन ऑफ इंटरसेक्शन मिलेगा हमें, और ये लाइन ऑफ इंटरसेक्शन में से कितने प्लेन पास हो सकते हैं? इनफाइनाइट प्लेन. बट इफ आई एम सेइंग दैट आवर रिक्वायर्ड प्लेन पासेस थ्रू दिस लाइन ऑफ इंटरसेक्शन एंड दिस पॉइंट, तो फिर कितने प्लेन होंगे? ये पॉइंट और ये प्लेन में, ये लाइन में से पास होने वाले एक ही प्लेन होगा. सो अगर ये पॉइंट इधर शिफ्ट कर दिया तो ऐसा प्लेन मिलेगा हमें. मीन्स सम कंडीशन इज ऑलवेज गिवन टू अस इन आवर एग्जाम्पल, बिकॉज फ्रॉम दैट लाइन ऑफ इंटरसेक्शन इनफाइनाइट प्लेन पासेस. लेकिन हमें कुछ तो भी एक पर्टिकुलर प्लेन का इक्वेशन निकालने के लिए एग्जाम्पल में कुछ तो भी कंडीशन दी होंगी. यूजिंग दैट कंडीशन आवर एम इज टू फाइंड आउट वैल्यू ऑफ व्हाट? लैम्बडा. बिकॉज n1 बार, n2 बार, d1 एंड d2 we will get from the equation of two plane. Now remaining part is just to find out the value of lambda, क्योंकि ये अगर लाइन ऑफ इंटरसेक्शन में, तो इसमें से कितने प्लेन पास हो सकते हैं? इनफाइनाइट. आपको एक पर्टिकुलर प्लेन का इक्वेशन निकालने के लिए वो पर्टिकुलर प्लेन से रिलेटेड एक कंडीशन दी जाएंगी. सी, फॉर every plane passing through this line of intersection, only the value of lambda is going on changing. You have to find out value of lambda for your required particular plane, and for that required particular plane some condition is always given in the example. That part we will see while solving the example. So now here we have got what? Vector equation of plane. Now we are trying to find out Cartesian equation of plane passing through the intersection of two planes. So here let us consider two planes in Cartesian form. So we can say that equation of plane passing line of intersection of planes. Let first equation is a1x plus b1y plus c1z plus d1 is equal to 0. So already we have seen that this is equation of plane in what? General form. But since two equations are there, that's why here coefficients are denoted by a1, b1, c1, d1, and in the second equation let us denote the coefficients by what? a2, b2, c2 and what? d2 is equal to 0. So equation of plane passing through the intersection or line of intersection of these two plane is same method we are applying here. In the first bracket write down what? First equation. What is first equation here? a1x plus b1y plus c1z plus d1 plus then lambda into what? In the second bracket write down equation of second plane. Lambda into what is the equation of second plane? a2x plus b2y plus c2z plus d2, and on this side keep 0 as it is. So this formula is applicable to find out equation of plane passing through the intersection of what? Two plane. Okay, so if equation of two planes are given to us, just substitute these equations here, you will get required equation of plane. Only the remaining part is to find out value of what? Lambda, because from the line of intersection infinite plane can be passes, isn't it? अगर ये line of intersection है, ये दो plane अगर intersect हो गए तो इनका intersection क्या होगा? एक line होगा. ये line में से infinite plane pass हो सकते. आपको कहा जाएगा कि find the equation of plane passing through this line of intersection and some particular point. तब ये क्या होगा? ये अगर point है और एक line, तो एक ही plane ऐसे pass होगा. So using that coordinate of a point, you have to find out value of lambda, or different conditions are given to us related with what required plane. Make the proper utilize of that condition to find out value of lambda. So how to apply the method while finding the value of lambda, that part we are discussing while solving the example. Now see how many formulas we have got here to find out vector equation and Cartesian equation. Again, let us revise all these things, and later on applying these formulas we are starting example from first exercise related with what plane. Now let us revise all the theorems we have proved to find out equation of plane. Some formulas we have proved in vector form and some formulas we have proved in what? Cartesian form. So first formula is what? R bar dot n bar is equals to a bar dot n bar. When this formula is applicable, if a bar is given to us, what is a bar? A bar is the position vector of a point on the plane. And what is n bar? N bar is a vector perpendicular to the plane. If these two values are given to us, at that time applying this formula we are finding vector equation of plane. Same formula we have converted in Cartesian form. What is that Cartesian form? A into x minus x1 plus b into what? Y minus y1 plus c into z minus z1 is equals to 0. To apply this formula, first required value is coordinate of one point on the plane. Here position vector of point is given to us, and here coordinate of one point on the plane is given to us. What are the coordinate of that point? x1, y1, z1. And what is ABC? ABC are the direction ratios of the normal. If these two values are given, coordinate of one point and direction ratios of normal to the plane, then this formula is applicable to find out equation of plane. Okay, so later on we are discussing very important part, that is general equation. So second result is general equation. Means after simplifying or after substituting the values in this formula, the result which you are getting is in this form. R bar dot n bar is equals to dot product of these two vector is a scalar. Let us denote that scalar by what? D. And after simplifying this equation, a into x, what will get here? Ax. B into y will be equals to what? By. C into z will be equals to what? Cz. And a into minus x1, b into minus y1, c into minus z1, these are nothing but what? Numbers. And multiplication of number is new number. Let us denote that new number by what? D. Means lastly, after substituting the values and simplifying it, lastly we will get the equation in this form, and which is called as equation of plane in general form. And this is Cartesian equation of plane in general form. This is vector equation of plane in general form. Now let us discuss about the next important result. Again remember that whenever the equation in general form is given to us, so here r bar dot n bar क्या है? It is vector along the normal. अगर normal पे का एक vector मिल गया हमें, so from that vector we are able to find out direction ratios of the normal. And if the vector is in general form, at that time coefficient of x, y, z means a, b, c are nothing but what? Direction ratios of the normal to the plane. According to next theorem, equation is r bar dot b bar cross c bar is equals to a bar dot b bar cross c bar. So this formula is applicable to find out vector equation of plane if a bar means what? Position vector of one point on the plane is given to us, and b bar and c bar are two vector parallel to the plane is given to us. Same formula we have converted in Cartesian form also. So that Cartesian equation of plane is x minus x1, y minus y1, z minus z1, b1, b2, b3, c1, c2, c3 is equal to 0. But remember that this formula is not given in the textbook. Just I have converted this equation in what? Cartesian equation. But don't apply this formula while solving the example, because this formula is not given in the textbook. So easily we are able to convert. First find out equation in vector form, and vector form can easily be converted in Cartesian form hardly within 1 or 2 steps. Okay, so then in the next theorem we have proved one formula to find out vector equation of plane passing through 3 non-collinear points. What is that formula? R bar dot AB bar cross AC bar is equals to A bar dot AB bar cross AC bar. Applying this formula, we are able to find out vector equation of plane passing through 3 non-collinear points. Which 3 non-collinear points? A, B, C. And the same formula we have converted in what? Cartesian form also. What is the Cartesian form? If x1, y1, z1 are the coordinate of first point, x2, y2, z2 are the coordinate of second point, and x3, y3, z3 are the coordinate of third point, then equation can be found out applying this formula. X minus x1, y minus y1, z minus z1 are the element of first row of this determinant. X2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1 and z3 minus z1. After simplifying this determinant, whatever may be the result we are getting, lastly the result is definitely in this form, which is called as what? Equation of plane in general form. And fifth important result is the normal form, means vector equation of plane in normal form or Cartesian equation of plane in normal form. What is that formula? R bar dot n cap is equals to P, where P is nothing but distance of the plane from the origin and n cap is a unit vector along the normal to the plane. Same formula we have converted in Cartesian equation, that is Lx plus my plus nz is equals to P. So if you'll observe both the formulas, because question can be asked to find out distance of a plane from the origin. So here P is nothing but what? Distance of the plane from the origin. But when we can say that P is the distance of a plane from, or value on the right hand side is the distance of a plane from the origin, if coefficient of x, y, z are what? L, M, N. If it is ABC, at that time we cannot say that the constant on the right hand side is the distance. When we can say that it is distance of the plane from the origin, if coefficients of x, y, z are what? Direction cosines, isn't it? And if the equation is given in which form? Normal form, at that time value on the right hand side is distance of the plane from the origin only if here unit vector along the normal is there. Agar unit vector along the normal nahi diya hai, so first convert this vector into what? Unit vector. कैसे करेंगे? इसी vector को इसके magnitude से अगर divide किया, so this vector will become what? Unit vector. At that time whatever may be the new value we are getting on the right hand side is nothing but distance of the plane from the origin. And lastly, we have seen just now, we have proved a formula to find out equation of plane passing through the intersection of two planes. What is that formula? R bar dot n1 bar plus lambda n2 bar is equals to d1 plus lambda d2. And even we have converted the same equation in Cartesian form. So what is that Cartesian equation? a1x plus b1y plus c1z plus d1 plus lambda into a2x plus b2y plus c2z plus d2 is equal to 0. This is the formula to find out Cartesian equation of plane passing through the intersection of two planes, and this is the formula in what? Vector form. So all these are nothing but formulas to find out equation of plane in vector form and what? Cartesian form. Again we will discuss few important result, so which are not given in the textbook but can be useful for competitive exams. Getting it? So now a distance of the plane r bar dot n bar is equals to P or is equals to D from origin is equals to. Okay, so now try to understand this formula. What is the equation of plane here? R bar dot n bar is equals to D. Now our normal form says that value on this right hand side is the distance of the plane from the origin only if this vector is what? Unit vector. अभी यहाँ पे यूनिट वेक्टर नहीं है, सो टू कन्वर्ट इट इनटू यूनिट वेक्टर वी आर डिवाइडिंग टू n bar by its magnitude. So what we'll get here, r bar dot n bar divided by magnitude of n bar. Since we are dividing to left hand side, that's why divided to what, right hand side by magnitude of n bar. Just simply we are dividing both side by magnitude of n bar. So now this vector is now what, n bar divided by its magnitude means it is unit vector. अगर ये unit vector है, then value on this right hand side is called as what, distance of the plane from the origin. So what formula we have got here, d upon magnitude of n bar. Here value of d and n bar we will get from the equation, and using normal form we are getting one formula to find out distance of this plane from the origin. Now if the equation is given in what, Cartesian form, suppose that equation is, now here we are finding distance of plane. Let the equation of plane is ax plus by plus cz plus or is equals to d, distance of this plane from origin is equals to. Now here equation is given in what, Cartesian form. What is that equation? Ax plus by plus cz plus d or is equals to d. Okay. Now we are finding a formula to find out distance of this plane from the origin. So now if I am dividing both sides by under root a square plus b square plus c square, see what we'll get. Here we will get a upon under root a square plus b square plus c square, x keep it as it is. Here also I am dividing by under root a square plus b square plus c square, y plus c upon under root a square plus b square plus c square, z, and on this side also we are dividing by under root a square plus b square plus c square. Now observe it very carefully. So what is ABC? ABC are the direction ratios. Then what are the direction cosines? A upon under root, b upon under root, c upon under root. Under root means under root a square plus b square plus c square are called as what? Direction cosines. But direction cosines are also denoted by what? L. This value is denoted by m, and this value can be denoted by what? N, because direction cosines we are denoting by Lmn. Now check whether this equation is in what? Normal form, Lx plus my plus nz. If the coefficients of xyz are direction cosines means Lmn, at that time value on the right hand side is called as what? Distance of the plane from the origin according to this formula or according to this theorem. So here this is the value on the right hand side, means if these are the direction cosines means value on the right hand side is nothing but what? Distance of the plane from the origin. So what formula we are getting here? D upon under root a square plus b square plus c square. Why we are giving mod here? Because distance cannot be negative. Okay, so in this way we have completed theoretical part related with what? Equations of equation of plane in vector form also and in normal form also. In the next video we will solve the examples in the exercise in which these formulas can be applicable to solve the examples.